Hello, everybody. Welcome to week 5, Chemistry 20, distance learning. And I'm not sure if you're watching this on Monday or later in the week, but I just want to let you know about something a little bit different this week. I'm going to open up a Google Meet question opportunity this Thursday. And for Chemistry 20, it'll be 10 o'clock a.m. So look for announcement and look for the link on Google Classroom a little closer to Thursday. All right, guys, we're going to keep on going with our Unit C, Matter, Solutions, Acids, and Bases, and we're really focused on acids and bases this week. And honestly, that'll be our focus until we're finished this unit. We have this week left and then one more week until we are on to Unit D. Time is actually kind of flying, which is bizarre. Alrighty, so let's get right into it. Guys, today we're going to simply do what I'm going to call an introduction to acids and bases. And I know that seems strange because certainly you've been introduced to them many times in your past. However, we're looking more at the theory behind them rather than simply characteristics. All right, let's get right into it. Now, this first dude is important for you to know in the world of acids and bases. Weird looking name, it's pronounced Arrhenius. So Arrhenius first really focused on acids and bases well over 100 years ago, so quite a long time. And ultimately, he recognized a few super important things. First thing is he knew water needed to be a part of this, so that was key. And he knew that ions were formed. Now, how did he know that ions were formed? Because the solutions that were made were able to conduct electricity. I mean, you can show that in a variety of ways. Back in the day, they would have honestly been able to put electricity through and get a light bulb to light. So that's a pretty cool deal. Now, we use conductivity testers now, which are even easier. Essentially, a conductivity tester, you've probably seen these before, but basically they have a little top part with 2 electrodes that go in, and then there's usually a reddish or orange light up here. And if you put the 2 electrodes into your solution, all right, here's your solution, put them in. As long as it conducts electricity, then the bulb will light up. And that's, again, conductivity testers at their most simplest. All right, let's keep going though. Now, since he knew that acids and bases conduct electricity, Arrhenius looked at that and said, okay, well, if they conduct electricity, then ions are present. And that's where he did the next leap. And he said, hey, for acids to conduct, I think it's hydrogen ions that show up. And for bases to conduct, I think that it's hydroxide ions that show up. Now, that honestly is probably what you know right now from an acid-base perspective. And we're going to focus on that today. But just be aware, the nature of theories is that as more information becomes available, the theory must change. And keep that in the back of your heads. All right, let's keep going here. Now, Arrhenius acids are doing something that is familiar to you. They're going to undergo ionization when you put them into water. So don't lose sight of these words that have been introduced to you in the last couple of weeks. And you should fill this out in your notes. You've got the HCl gas sitting there already. Essentially what's going to happen is we have that HCl gas, and as we add some H2O to that hydrogen chloride gas, the acid is going to ionize. So you're going to end up with that H plus aqueous, and that's the key one. And we're also going to go, because if that hydrogen, think about what's happening, right? That hydrogen leaves, it ionizes, then we still have the anion left over, the chloride anion. Now, we've done this before. This is ionization. Now, the most important aspect there, according to Arrhenius, was this dude, right? That H plus aqueous, which gives an acid its acidic characteristics. Okay, now an Arrhenius base, on the other hand, when we look at this one, then the key thing, according to Arrhenius, is you will see hydroxide in the formula. And not separation, not ionization, this is dissociation. We are dealing with an ionic compound with hydroxide in the formula that when we add some water to it, we end up with the ions splitting apart Na plus aqueous plus hydroxide aqueous. And again, this is our key factor. Hydroxide giving the base its particular characteristics. All of this comes down to Arrhenius theory of an acids and bases. So ultimately, guys, an Arrhenius acid, and this is important, please, for you to associate in your head, is a substance that, not a new word here, ionizes, right? It's ionization to form those H plus ions. An Arrhenius base, on the other hand, does not ionize. Instead, it dissociates. And it dissociates to form hydroxide ions. Now, you should be hearing all this and being like, yep, I know this. That's familiar. All that's new is this dude Arrhenius. Now, again, have this in the back of your head. Yes, this is the Arrhenius theory, but what if we continue on into a modified Arrhenius theory? Okay. Now, guys, before we get into that modified Arrhenius theory, let's just really quickly recap some of the characteristics of acids and bases. Now, this whole sheet in front of you is not in your notes, but it's complete review from past courses that you've done. Litmus paper, of course, in an acid is going to turn red. In a base is going to turn blue. The pH scale, don't lose sight of this too, please. Neutral is at 7. As you go into a lower pH, this is where it's more acidic. That's why I have it on the acid side. As you go into a higher pH, that's where more basic. Acids will always conduct electricity, as will bases. We'll talk more about reactions with active metals, but just know that acids do, bases don't. And the tasting thing is familiar too. Sour versus bitter and a burning feel. Bases also are quite corrosive. However, they're also used for soaps, which is kind of interesting, especially in this age of COVID. Anyway, guys, I would like you to do the first part of your weekly assignment now. And there's a good reason for it, because that number one question is a lab investigation, and it relates directly to this Arrhenius theory. And trust me, it makes a lot more sense for you to do this first, explore it, and then we'll get into the modified after you've gone through the lab investigation. If we were in class this week, this is one, of course, we'd be doing in the lab and investigating. So in this regard, it's a little different. You have to read it all through, look at the evidence that's already been given to you, and go through the analysis. Alrighty, talk to you soon in the next podcast.